So here's section 7.1 notes. You are now going to apply the Pythagorean theorem to either find the hypotenuse or a leg of a right-angled triangle. So here, if we look at our triangle here, remember the two legs are kind of surrounded by the box, which is the 90-degree angle, and the hypotenuse is always across from what we call the 90-degree angle, as you can see here. Now you guys should have learned about the Pythagorean theorem really early on, but just kind of refresher, remember the Pythagorean theorem saying that the square of the length of the hypotenuse, which is in this case c, okay, is equal to the sum of the squares of the lengths of the legs. So in simplest term, meaning c squared equals a squared plus b squared. So in our first few examples, we are basically going to use just that equation or that formula to find our x. So in example 1, we're going to find x. Now make sure you write your answer in simplest radical form. Now we've worked on simplifying radicals. Now we're going to use that when we're trying to solve for x. Okay, let's go ahead. We're going to do part A. So here we have 8, 6, and x. So here 8 would be considered our leg. And then 6 would also be considered our leg. So that means our x is really the hypotenuse. Okay, so that's what we're trying to find here. Okay, using our formula, we have c squared equals a squared plus b squared. Okay, so remember c represents your hypotenuse. So in this case, we're going to represent that as x squared because we don't know what it is. Now, a squared could be anything. It could be your 6 or your 8. It just needs to be one of the legs. So let's go ahead. I'm just going to put 8 squared here. And then plus, now we plug in our other leg, which is the 6. So 6 squared. So now we have x squared. And then make sure that you calculate 8 squared, which is 64. And then plus 6 squared, which is 36. So we have now x squared equals, now we add 64 and 36 together, 100. Now, what we need to do is get x all by itself, meaning we can't have anything in front of it, we can't have any exponents, etc. So we have this squared. Remember, the opposite of a squared is what we call a square root. Now, yesterday, we went over what all the perfect squares are. And if you remember, you can get your notes out. If you don't, 100 is actually a perfect square. So we now have x equals, and then basically the square root of 100 is 10. So our answer for this one is just basically 10. So really it's very simple, just figuring out your x value so that either can be a leg or a hypotenuse. So go ahead, I would like you to try the next one. Here, if you look, x is in a little different spot. So remember, if we look here, because it's in between our box, this is what we'd be calling our leg. So you're now actually going to find the length of one of your legs. And then 8's the other leg, and 17's your hypotenuse. So make sure to go ahead and pause the video, and then go ahead and solve for x. So hopefully you paused the video so you could try this on your own. So now we're going to go over this. Now, I'm going to rewrite the formula of the Pythagorean theorem. C squared equals a squared plus b squared. There you go. So c squared equals a squared plus b squared. There you go. So in this case, our hypotenuse is 17. So we already know our value for c. So we have 17 squared. Now remember, a is just one of the legs. You can pick any leg you want. So I'm going to go ahead and pick, let's see, our 8 for that. So I'm going to do 8 squared, and I'm going to do plus, and then now x squared is our other leg. So now I have to calculate 7 squared. So that should be, I think, about 289. Okay, that's an 8 right there. Let me rewrite that so it looks a little bit better. So we have 289 equals, remember 8 squared is 64. If you don't remember this, all you gotta do is put this into your calculator. You can either do 17 times 17 or just do 17 squared and then plus x squared. Now here what we have to do is get x squared all by itself. In order to do that, I need to subtract 64 from both sides. So here, this cancels out. Now we do 289 minus 64. So you can use your calculator to do that. We should get about 225, which equals x squared. Now remember, x has to be all by itself. We can't have a squared. We can't have anything in front of it. Now here we see we have our squared. Whenever you have that, you have to take what we call the square root. Basically what you're doing is you're canceling out that squared with the square root. So now we have x. Now looking back at your notes, okay, remember in this case 225 is a perfect squared. So we are going to get a very nice number when we calculate that, okay? So now you're going to take the square root of 225. Now if you don't know how to do this in your calculator, you can always email me or come in before or after school to ask about that. Or you can just look it up on Google. That's like another way of doing it. So the perfect squared is going to be 15. And that's your final answer for that one. Now, if we go to C, you kind of see it's a little bit different because here, usually we just had, whole numbers. But now we have square root of 19 and square root of 7. So let's see how this works out when we are solving our problem. Okay, so if we look here, here's our x. Now, this is what we call our leg, right? Square root of 7 is also a leg. So both your legs are always surrounding the 90-degree angle or the box here. And then your hypotenuse is always opposite of your 90-degree angle. That's how you can always tell which one's your hypotenuse. Okay, remember we use c squared equals a squared plus b squared. That is the formula we are using. Now here, we already know our hypotenuse. Hypotenuse always goes into the C area, so we put it in here. So that's going to be the square root 19. And now I'm going to put parentheses around here because I am squaring that square root of 19. So I make it equals 2. And now a squared, remember, that is either one of your legs. Does not matter which one you put. I'm just going to put x squared here. Plus, and then I'm going to do square root of 7. So I'm going to do square root of 7. Once again, I'm going to do parentheses and then put a square there. Now, usually when we square a number, you do, that number twice, multiplying it twice. You're doing the same thing here. You're really just doing the square root of 19 times the square root of 19, okay? So I'm going to show you what this would look like in a calculator if you want to calculate it, and then explain what's actually happening. So we are going to put the square root of 19. Now, I'm going to put parentheses around this, and I press second. Now, this is using a graphing calculator, but a lot of the scientific calculators do the exact same thing. So you do second, and you want to do x squared for your square root. So now I'm going to put 19, and then here I do have to arrow over so then I can close it. And now where that x squared button is again, I'm going to square it, okay? Now if I press enter, oh, I just get that number that was underneath the square root sign. So I get 19 here. The reason being is, remember when we took the square root of a squared, basically we said that it canceled out. You're doing the same thing, just kind of reverse. So we have a square root, and our square, they basically cancel each other out. So when they cancel each other out, you're just left with what's inside. So in this case, it's 19. So x squared, we just keep it as x squared. And let's see what happens when we do the square root of 7, when we plug that into our calculator. So I'm going to do the exact same thing. I'm going to do parentheses. I'm going to press second, the x squared button, so I can get my square root. Okay. Now I'm going to plug in 7. Got to arrow over so I can finish off my parentheses. Then the x squared button again, so then I can get my square. So then I should get, well, 7. Because basically what's happening is that square root and the square are just canceling each other out. Kind of like this. You can kind of like X them out like this. And then really you're just left with what is left inside that square root sign. So now what we do is we want to subtract 7 from both sides because remember we're trying to get that x squared all by itself. So we're solving for x. So I subtract 7. So on this side, on my right hand side, I'm left with x squared. Now I do 19 minus 7, and that should give me 12. So once again, we're trying to get x squared to be all by itself. To get rid of it or cancel it out, I got to take the square root of both sides. Okay? So now I'm left with, down here, equals x. But if we look at 12, we now know that is not a perfect square. Well, because it's not a perfect square, we now have to simplify it if possible. So we are going to find two numbers that multiply to 12, and one of them has to be a perfect square. So if you want to start off with 1, okay, 1 goes into 12, and that's a perfect square. But you always want to find the biggest perfect square that goes into your number. So let's think about the next perfect square, which is 4. Well, 4 goes into 12, right? So we know 4 goes into 12, and we say it goes into 12 3 times. So now what we have rewritten is the square root of 4, and this is multiplication times square root of 3. So now what we're going to do is take the square root of our perfect square, which is the square root of 4. So if you take the square root of 4, that should give you 2. Now 3 is not a perfect square, and we can't simplify it anymore other than saying 1, okay? But really we don't take the square root of 1. So because we can't simplify anymore, we have to leave it inside the square root sign. So now we say times the square root of 3. So our final answer in this case is 2 times the square root of 3. And that's what our x value is going to be. And remember, you have any extra questions on this, come into class with those questions, or you can come in before, after school, or you can always email me. Now, the next part, we're going to use the Pythagorean Theorem to solve real-world problems. So let's look at this example, okay, example 2. It says the 16-foot ladder rests against the side of the house, and the base of the ladder is 4 feet away. Approximately, now we got to remember that word, approximately, because we're going to round a little bit later on, how high above the ground is the top of the ladder? Now, they kind of already gave you a picture here, okay? So here's the 4 feet. Here's our x right up here, and then 16 is what we would call, remember, because it's across from the 9 degree, is our hypotenuse. So we already know that our 16 is the hypotenuse. Then we know that the x is going to be one of our legs, and then the 4 feet is going to be one of our legs. Okay. So now all we have to do is use the formula c squared equals a squared plus b squared. Really, I'm just using the picture to kind of help me out where to plug things in. Now remember, c represents your hypotenuse, okay? So because of that, with our hypotenuse of being 16, I do 16 squared. Now remember, a is just one of your legs. It does not matter if it's the 4 feet or the x. I'm going to go with x, so I'm going to go x squared. But you could also put, in this case, if you wanted to, 4 squared. Now I'm going to do plus my other leg, which is 4, and then square it, okay? So now I got to do 16 squared, so calculate that. So that should be 256. And really, all I'm doing, if you want to plug into your calculator, is do 16, and then press that x squared button to do that. And you should get 256. Or you could just do this, 16 and then times 16. That's basically what 16 squared means. You're just multiplying it by itself twice. And you should get the same exact answer. So now I have x squared. And so now with my plus 4 squared, I got to calculate that. Really, you should know that. That should be 16. So now what I need to do is trying to solve for this x squared, I have to subtract 16 from both sides. Remember, we're trying to get that x squared all by itself, okay? So when I do that, I'm left with x squared on the right-hand side. On the left, I do 256 minus 16, and that should give me 240. That's 2 right there. Good. Now, just like we did before, we have to get rid of this squared. In order to do that, you have to take the square root of both sides. Now, because this is a real-world problem, we don't have to leave our answer in simplest radical form. We can actually take the square root of our number. So we're going to do that and probably round to the tens place. So I'm going to press second and then the square root. Now our number was 240, so to 240, and then I'm going to press enter. And so now we know it's going to be 15 point, and let's round to the tenths. Now if our hundredths right here is 9, that means I got to round up. So our final answer really in this case is we have x, which equals 15.5, and make sure you use labels, and we're using feet, right? So we would say 15.5 feet. And then this would be our final answer. So really x is about approximately, and do those squiggles to indicate approximately 15.5 feet. So when you do word problems, it is okay to take the square root and not leave it in radical or simplest radical form. But whenever you do these calculations, just like in example 1, you need to leave it in simplest radical form because it tells you to do so. Okay, I would like you to try, whoops, you kind of saw a little bit there, but I would like you to try the second word problem. It's going to be very similar to the next one. So pause the video and try it on your own. Okay, so hopefully you paused it and tried it on your own. So now we're going to go over this. So let me kind of label the sides. Now here's our 90-degree angle, the box. So that means this 125 inches is our hypotenuse, okay? And then the other two are legs. And so the 120 is also our leg. There we go. So kind of to save on time though, I'm going to show you the answers, okay? And you can kind of pause it if you want to, and then kind of look through if you got it correct. If you have questions on the second word problem, then you need to come in to class asking that question. So here's my work for the second word problem using the Pythagorean Theorem. So go ahead and pause this so you make sure that you can see everything up here, okay? And then if you have any questions on anything over here, make sure you email me, or you can come in before or after school, or you can just come to class and ask those questions.